thank you for having me here. Thanks, Mats, for building such a nice language for us to work with here. The kind of thing that I wanted to try and answer in this talk is a bunch of questions that perhaps some of you guys have been wondering. The first one is sort of like, so who's actually working on this, and what are their names and all that stuff? So the folks that are on the team, Haibo's not here. He's back writing more tests, right, to make sure that keeps us honest. But Tomasz, can you stand up? And John Messerly, who's beside him, please stand up. Those are our two devs that are also working on IronRuby, as well as a host of other contributors that are just kind of gearing up inside of the community, and we'll talk a little bit more about those guys as this talk goes on. Probably the biggest question that I want to consider is why, right? So why are we doing this? Why is it interesting? There's a whole bunch of kind of interesting themes. So why is really the theme of this talk, right, to allow us to kind of think about and frame the rest of the stuff that we're going to talk about from here on in. So one why is, why am I working on this thing? Because I used to live in that place. That place is Toronto. Last year when I was here, I announced my intentions to leave Toronto. And in sort of like the intervening year, we've kind of settled very nicely here. Here is a pumpkin in my house in Seattle, which is actually a remarkably beautiful place to live if you haven't gone up to the Pacific Northwest before. And I live in this building now, right? This is building 41 at Microsoft. So why did I do this, right? Why did I kind of like uproot my family, my kids, and all that kind of stuff to kind of move to this other country to work on this project? It turned out to be something that I could not do, right? I started off working on another open source project called Ruby CLR, right? Which kind of I built a bunch of bridges. I kind of forgot about this other thing I did for Delphi a long time ago until last night when I was talking to some people. But I've been kind of building these bridgey kind of things for a while, right? And I kind of like it. I like bridging these kind of different worlds and different technologies. And Ruby CLR was a bridge between the Ruby language and the CLR. And when this kind of opportunity presented itself to work on a real implementation of Ruby on top of the CLR, it wound up being one of those things in which you kind of have to sit there and say, well, how many opportunities really get, right, to try and do something significant, big, and different and stuff, right? This was just one of these things that really couldn't use. And since getting to the company, what was fascinating is, I remember, so the story I was just telling Rich down there this morning was how during my interview, right, at the company, when I was interviewing, I thought there was sort of like this tinge of arrogance, right? Microsoft, as of course it has that, in which it seemed like building the language was almost an afterthought, right? It was, but of course we can do this, right? And I was sitting there going, well, wait a second, that's kind of unusual, right? This is a language which has a reputation for being difficult and a number of other things, but yet there was this confidence, right? This is just going to be done, right? We'll figure out some way of doing this. And in sort of the intervening time since I started at the company, and I started seeing, the quality of the devs that we have on our team, right? This is absolutely stunning, right? It's been a real privilege to work with these folks because it's not until, you wonder, how well you can do in writing software and the rest of that stuff, right? You have to measure yourself against other people, right? And I think that if you download the source code, right, for IronRuby, you can go and look for yourself, and I highly recommend that you do so, right? It's some of the nicest source code that I've certainly seen. And it's been a privilege for me to work on this project. Now, what's interesting is when you get to a place like Microsoft from being outside of Microsoft, it's interesting how perceptions change, right? It's a matter of perspective, right, about what is what, right? So whereas formerly, it was kind of fun to work on, open source and all this other stuff, outside of the company, the minute you kind of get into the enclave or the hive or whatever you want to call it, all of a sudden everybody thinks that something has happened to you, right? Something bad, or maybe, that the implant goes in and people start preventing you to do things that you might want to otherwise do. So another part of IronRuby, and one of the kind of things I like to talk about as a meta point about the language, are some of the other goals of the project as well, right? So the goal obviously is, well, let's build an implementation of Ruby, but there are some other goals inside of the project as well, which are kind of more meta-level goals. So what's interesting is how hard it is to try and affect change, right? You know, so one of the other funny things, I remember I was at this event, and you know, and Steve Ballmer was at this event, right? And what was interesting about this event was how he was talking about recruiting, right? And Microsoft is one of these companies that recruits very aggressively out of college. And talking to the hotshot CS grads, right, coming out of the schools, that, you know, obviously search is an important thing at the company, right? So he was talking about, you know, so who are you going to go work at, right? Are you going to go work at Google, right, and raise their search engine market share from 66 to 67%, right? You know, like whoop-de-doo, right? Come work at Microsoft, where every day is a potential day, right, to continue to do great things, right? Because you can only go up from where we are now. So that was the way he kind of described that, which I thought was a very funny way of looking at it. So it's sort of like the other thing, right? If you want to work on open source, right, you know, every day, right, is a day where you can only go up, really, right, at Microsoft, right? So I think that there's some, you know, fun ways that you can kind of look at that, and this is something that a lot of folks think, the company, and certainly there's a lot of folks inside of the company that believe in stuff like this, right? This is actually the title of a book. And, you know, the interesting thing about that is, you know, yes, I think it's very important for the company to figure out, you know, what to do about open source, because traditionally, right, at the company, it's always been it's an either-or thing, right? You know, it's either, you know, our stuff or all that other stuff. But the reality, obviously, with a lot of customers is it's no longer like an either-or thing, right? But it's more of a, how would I say it? It's an and thing, right? Because obviously, right, you know, both things are there and both things are not going to go away anytime soon. But now, there's some challenges, right? So if you want to ever change things at companies, right, you'll see that if you look at those things, right, the demise of the company has been kind of greatly exaggerated, right? So it's really hard, right, to affect change at a company. Think about it, right? When the company's doing really well, right? When the management's sitting there saying, well, if you look at that, right? Those are all things that happened a few weeks ago. You know, it's really hard when, you know, effectively, if you're a manager of the company, right, and you're looking at objective numbers and you're saying, well, you know, are we increasing shareholder value, blah, 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 that kind of stuff, right? Sure, yeah, right? And so, you know, when you're saying, but no, you got to do all this other stuff, right? You got to figure out this open source thing, right? When you're looking at results like that, right, it's kind of hard to say, well, is there anything that we're really doing wrong, right? So that's part of the challenges, right, that kind of, you know, sit in front of a lot of the folks that work in the kind of area that I work in, right? So I work on a product team, but we've also got folks at the company who are very instrumental in trying to get, you know, this kind of change, right, this kind of larger change to happen. So obviously there's this thing, right? I think that it's also very important for people to realize how it's very easy, right, to try and sit there and just say some stuff, right? To say a bunch of words, and certainly people with blogs, right, have certainly shown this, right? You know, there are pundits everywhere. To kind of like, you know, tell an interesting backing story around this, we announced all of our intentions and our projects, you know, both IronRuby, DLR, IronPython, as all being certainly at that time, we called them shared source projects. We're very careful about that. That were, you know, released under this license at Microsoft called the Microsoft Permissive License, right, which is a BSD style license. So we showed that. We gave some demos. We showed some stuff with Silverlight, which of course confused the hell out of people, right, because people thought that all our stuff would only run inside Silverlight, nowhere else, and so we had a bunch of things. But sometime between that and us shipping some code out to the world, one of our specs leaked. So this was one of our specs, apparently, right, where we kind of built this this thing, right? And certainly, you know, this was, so a bunch of people went out into the world and started looking at, and certainly the pundits came out, right? So the crazies, certainly Rockwell, right? There's some crazies over there. And so it's fascinating. You really should go look up that article, right, and read through the 700 comments or so, right, that, I kid you not, right, that are sitting underneath that. Just to kind of get some idea about how we hadn't shipped anything yet, right? But because we're Microsoft, right? All of a sudden, of course, everything has to be really bad and evil, right? So, there's a kind of like a nicer kind of like trajectory that we've got here, right? Where we're now, over time, right? We're starting to get better at doing things, right? So this happened only a few weeks ago, where against certainly all of the pundits out there that were saying this, we managed to get our licenses, which is the Microsoft Permissive, which is now being renamed the Microsoft Public License. So if you actually look, right, the only difference is changing that one word, right? It went from permissive to public. But it's now an official open source license, right? So we can actually call this an open source project with a capital O and an S, whereas before we certainly couldn't have done that. So there's some interesting change and there's some positive signs coming out of the company. Another thing is, one of the things that we announced a long time ago was our intention in the IronRuby project to take contributions back from the community. So not only have we done that, we're hosting the project on a non-Microsoft site, right? It's up on RubyForge today. You can grab the sources. It's under this MSPL thing. It lives in Subversion, all that kind of stuff. And just again, about a week or so ago, we got our first contribution, right? Our first significant code contribution, right, back into the community. And that's Kurt Hagenlocker there, who submitted some patches, right, for some of our libraries. So this is, again, some really nice signs about, our project in its early steps, hopefully doing all the right things and being, true to the ideals of, what Ruby and what the Ruby community is all about. Some other kind of interesting things, right, since, there's certainly a lot of folks in the audience here who like shiny new things, right? And certainly functional programming languages are about the shiniest of the shiniest new things a lot of folks are into. Some more encouraging signs is, taking a former MSR project in functional programming in FSharp and turning that also into a fully supported real product inside of Visual Studio as well, right? So that's a project that Don Syme and his folks over at MSR in Cambridge have put together as a language, and this thing is also going to be in there. So, so the company is certainly spending a lot of time in investigating in new areas, right, from dynamic languages with our work in DLR, right, to also other paradigms of languages in languages like FSharp as well. So that's also interesting. All right. So what's our roadmap? What are we doing? And where do we go from here? Now, so there's this thing, right? I'm sure you guys have heard about it at some point in time. We've got certain goals for our project, right? And some of these goals in our project have been, again, speculated upon quite a lot. And one of the speculations was, oh my God, well, Microsoft, they make this thing called ASP.NET. Maybe you've heard of that. And that thing, there's no way Microsoft is going to allow a competing technology, right, onto their platform, right? That wasn't invented at Microsoft. Well, the reality is that if you think about it, Microsoft's a platform company, right? So why do we care? As long as you're running this stuff on Windows, if you were, right? Nobody's forcing you to do this stuff, right? Why does it matter, right? So, a lot of people were speculating, oh no, Rails will never run on top of IronRuby because, John's handlers, right, will just simply never let them do that, right? But it's silly, right? This language would not be Ruby if it didn't run, arguably the most important application on Ruby, right? So this is effectively our test bed, right? If it doesn't run this thing, right, it's not Ruby. So, so this is one of our key goals is to be true to the language, right? We've got some track record, not certainly in Ruby, but in Python, in our same team, right, in accomplishing those goals, right? If you look at anything that's being written about IronPython, certainly, the overall consensus is that we've tried and bent over backwards as much as possible, right, to maintain absolutely compatible with the Python language, modulo certain things that simply are not possible. Right? So here's some other stuff, right? Not only do we want to make sure that our stuff runs the Ruby language, but another really important component, our second goal in our project, is to make sure we have excellent .NET environment. So we want to be able to run everywhere that .NET runs as well. Right? So certainly those are three platforms where .NET runs today. Right? You might be surprised by the one in the upper right-hand corner or not. Right? That's what Mono and the folks over at Novell have been building, and Miguel and his band of merry men have been building for quite a while. Right? So we can certainly go off and run stuff over there as well. Right? So certainly all three of those platforms IronRuby is going to run on each one of those things, as well as the DLR. So remember, DLR is released under MSPL, right, the public Microsoft public license, BSD style license. So effectively what this means is that anyone can simply go off and ship the DLR code, right, that runs on top of Mono. right? You don't have to do anything or anything else, as long as Mono continues to run. In fact, Mono can simply run our binaries, right? So you can compile on Windows if that's what you want. And actually, if you think about how many people here track Mono reasonably closely? Right? So you know that the Mono folks have been kind of like hacking linked into their compiler recently, right? And so they're breaking things in a number of interesting ways. So what they discover is every time we do a new source code drop for those guys, right, is that, we wind up breaking Mono in interesting ways. But those guys wind up fixing things remarkably fast at the same time, right? So it's generally only about a week or so before they get unbroken from things that we've done. So a third goal of our project is to essentially use it as a test bed for some performance work, right? So the DLR itself essentially handles a lot of the heavy lifting for people that are interested in implementing languages. Essentially, what you do is you generate a DLR tree, you hand it to us, and we do all the code gen for you, right? Much like, the JVM or the CLR, right? You build a compiler, you generate, instead of a tree, you generate a serialized representation of a tree, right? You hand it over to the runtime, and it goes off and makes things go fast, right? So the idea is that the language implementers don't have to worry about the making things go fast part. They can worry about the let's make a compatible language part of the story, right? And instead, the folks working on the runtimes can worry about the how do I make things go fast part of the problem. So let's before we go into that, let me just show you some stuff running, right? So this doesn't turn into a completely content-free talk, right? So over here, right, this is our code running on top of Mono. So if you go off and look at IronRuby here, so this is the stuff that we compile. Now, I could compile under Mono, and I could show you a compiling under Mono, and it actually does compile under Mono, but it doesn't quite work. So instead what we did was we compiled under Windows and copied those binaries, right, over to here, and we're essentially running a bunch of binaries that we compile with our compilers due to these little issues that are inside of Mono today. So the cool thing is we can take these assemblies, right, and simply run them under Mono now, right? So that is, the IronRuby REPL loop here. And so, you can do the classic, does it know how to add stuff, right, which is always the first thing that you do in a REPL loop, right? Make sure, at least the language. Actually, what was interesting was initially, once we first shipped the language, one of the first things people did was try to do some math and discovered that, well, we didn't implement things like subtract and other things like that, right? So, details, right? But we've got subtraction working now, right? So, so some of the other things I wanted to show you is some of our work on .NET Interop, right? So right now, this is just Ruby running in here, right? But the minute that you go off and require something like MS Core Lib, that brings into visibility, right, the .NET types. So this lets you go off and do things like, let's go off and create, my favorite thing, the system array list. Right, so we'll go off and create an instance of that. And of course, you can imagine doing all of the standard tricks like that, and adding things to array list, reading some properties. Tomasz will be happy I said count instead of length. And so you can see that kind of stuff works. And if you've seen my parlor tricks with Ruby CLR, you'll see that all of the parlor tricks are alive and well, right? So you can call things using Ruby-style names as well. You can retrieve things by essentially calling the indexers, right, into the array list. Remember, this is a .NET type on the other side. But what's also interesting is you can also do Rubyisms here as well, right? So you can walk over this thing. Ooh, what is that? Okay, let's try this again. Oops. So you can go off and each over something, right? So that's kind of cool. But some other things you might not expect is you can go off and first, last, reverse, right? All those other kinds of things, although that's not all that impressive, right? See, it works. As well as, some other things, some other mixins, right, that might show up as well, right? So we can go off and do things like, we can map over a bunch of things, right? Right? So, not incredibly exciting things, but the nice thing is this is a nice bit of integration, right? Because what we do under the covers is any .NET type that implements the iList interface, we mix in the array methods on it, right? because it just makes it feel more like an array, because effectively that's what an iList is, right? It is an array. Our implementation of a native Ruby array is also itself a list of objects, right? It implements iList. So, so some of these really interesting ideas, right, we've been experimenting with inside of our implementation, right, just to make the .NET interop more seamless, right, make it feel more natural when you're programming against types that were created by, some other language. Now, some of the other cool things that we can do is we can show off some generic stuff, right? So, again, in Ruby CLR, one of the parlor tricks that we had there was the ability to go off and create new types. So how about a list of int, right? A list of int is simply a system, collections, generics, list.of, right? Some type, right? And the type is system int32, let's say. So system collections, generics, list.of. Maybe this doesn't work on our model. This works under Windows. So, pardon me? It's generic? Yeah. What do you do without IntelliSense, right? I mean, this is what's happened since I've gone to Microsoft, is I can't type anymore. That plus the 3 hours of sleep that I got last night. So there we go. So now I can go off and create an instance of this guy, right? List of int. Does that look like I didn't type anything wrong? It's Mono's fault, right? Okay, so we'll blame Mono, and we'll bail out of this thing. I'll show you this thing running under Windows. Oh, maybe not. We'll see. Okay. Now, some of the other interesting things, let's kind of switch back over to here for a minute before we show you some other little tricks, is this performance thing, right? And there was an interesting project back in the late 1990s, early 2000s. There was a project called Project 7. This was something that was kicked off at the company right around the time that .NET itself was launched. And this project was kicked off to try and invite members in the community to go off and build languages on top of this thing that we're calling, it's called the Common Language Model, to see whether or not, in fact, you could go off and build other languages on top of the CLR. And as it turns out, I was at the meeting at the PDC that year where some of the results were presented. And perhaps the most damning indictment of the CLR was delivered by some folks over at ActiveState, right? ActiveState, yeah, you guys all know ActiveState. And the guy was this German guy with a French name, or a French guy with a German name. I can't. But anyways, he was really depressed, right? His entire talk was all about, well, I tried this and it didn't work, and I tried that and it ran really slowly, and so this kind of meme went out, right? This idea that the CLR was fundamentally hostile to dynamic languages happened, right? So certainly John Udell, right, certainly reported some of this stuff way back when. As a bit of a disclaimer, by the way, right, we hired John Udell recently. He was in our new employee orientation class, right? But all of this stuff was certainly written long before he joined up. Now, this is sort of like the roadmap that shows what we've done performance-wise inside of IronPython. Now, the first two things first three things are the CPython implementations. And IronPython 0.1 is the first interesting data point. IronPython 0.1 was a project that was created by Jim Huguenin. Jim Huguenin created Jython on top of the JVM. He also created the AspectJ compiler. And so Jim decided to go off and do this little experiment, right? Because since he wrote Jython on top of the JVM, he was wondering, how on earth did Microsoft screw up so badly in designing the CLR, right, that the perf would be impossible to build a performant, language, right? Because Jython runs exceptionally fast, right, on top of the JVM, right? So IronPython 0.1 was a result of about 3 weeks worth of Jim hacking, right? And you can see that at that point already, right, IronPython 0.1 was significantly faster, right, than the existing CPython implementation, right? So long story short, right, he got absorbed into the collective, and but he saw this as an interesting opportunity, right, to see exactly how far you can push the implementation of dynamic languages on top of CLR. Now, some of the things you'll also discover when you go off and you start building languages on top of another runtime is that your initial performance results may be a bit optimistic, right? So what happened was, what you don't see here, right, is how Iron Python started off going really fast and then slowly got slower and slower and slower, right, over time, right? Because certainly you start adding features to your language, and as you add features to your language, maybe in some critical steps you have to do an additional compare or some other thing, right? So things start running a little bit slower over time, right? But with some additional technology infrastructure changes, like a newer version of the CLR, for example, which happened at the IronPython 2.0 stage, you get a lot of performance increases simply due to tuning that's been done in the underlying platform or due to new features that were added to the underlying platform as well. Right? So CLR2 adds a feature called dynamic methods, which allow us to generate garbage collectible methods, right, at runtime. So that feature I used extensively in Ruby CLR, and we also use extensively inside of the DLR as well in order to achieve a lot of our interesting performance. So after the release of IronPython, you saw that John certainly published this thing here, which is really nice, right? John's a very balanced guy, right? Perhaps one of the most objective journalists, right, that was out there. He was the editor-in-chief of Byte and stuff before the demise of that magazine. Now, here are some of our current results, right? So we published some of these numbers way back when we first went public at OSCON. And these numbers here, right, these really useful programs, right? We were faster at OSCON. If you remember that number, it was 4.8 times faster. We're now down to 2.8 times faster, right? So, this is compared to MRI running on Windows, okay? Which, of course, is compiled with a 10-year-old C compiler. So you get some of the ideas. So this is while loop, right? Here's some other numbers. This is string concatenate, which is, again, somewhat surprising because we're a little bit faster even though we're pushing twice as much data around. So there's something buggered up somewhere, but we're not sure where. App raise, right? Here's a case where we are clearly slower, but we don't care, right? In this particular case, right? So throwing exceptions is something that we will never be fast on, and we really don't worry too much about being slow and throwing exceptions. All right. So back to the DLR, which is essentially the underpinnings of a lot of the stuff that are happening here. It all started, obviously, with Python, right? In Python, originally, this wasn't the dynamic language runtime. This was the Python language runtime. And, so it started off as that idea, the idea that, building Python was harder than it should have been. So let's try and factor out some of the core pieces of Python so they could be reused by other language implementers, right? And since that, as the DLR has been evolving, a while ago, we realized that we had to build a number of different languages on top of the DLR, right? Because you can't call it, again, a common language runtime or a dynamic language runtime generically unless you've implemented more than one language. So certainly, JavaScript, Visual Basic, and Ruby are projects that we're building at Microsoft, right? Ruby and Python directly from our team, and JavaScript and Visual Basic by some other teams at the company. Perl, PHP, there's a number of other folks that have also announced intentions to build stuff. Some are further along than others in terms of building their implementations on top of the DLR, right? But certainly there's, APL is probably one you didn't expect to see in there. Or even Boo for that matter, right? Because Boo isn't a dynamic language. But they want to add more dynamic features, right, to Boo, which is essentially a statically typed Python, if you're wondering. But they're very interested in dynamic language interop, so again, they're interested in using the DLR for that. So the interesting thing about the DLR is you can opt into the set of features that you want to use. You don't have to use all of the DLR, so you can just use it for doing things like, gee, we would like to simply go off and dynamically bind to things, and we can go off and use the DLR features just to do that. So let's take a little bit closer of a look under the covers of this thing a little bit more, right, so we can get a better feel for what this thing can do. So we go over to here. Let's get rid of that. All right. So if you look at our implementation now, there's a couple of things that I want to point out. If we go off and run some of our tests here, if we go rake specs here, this will go off and run the Rubinius spec suite, and you can see the kind of pass rates for things that we had there. String is easily the worst implemented of our things, so you can see all sorts of things blowing up in there, right? But we run these spec suites a lot, right? So this is an example of us reusing some stuff that other folks have done in the community, which is a wonderful piece of work, by the way. I highly recommend it to look at these things. And if you ever wondered, how some particular library works, these guys have done a very good job of trying to figure out all of the observable side effects, right, in implementing libraries, right? So you can see, how we're doing much better on array. Right? We've actually put a lot of effort in array, thanks to John Messerly over there, and we're passing the array specs today at a 90% rate, right? So that's going pretty good for our language. And of course, there's a scary dump of all the things that fail. But the three types that we are looking at here are array, string, and hash, right? So right now we're failing 373 out of that. Most of those things coming out of hash and string, right? Array, again, is something like 370 out of 400, right, are passing, right, inside of array today. Right? So that's really where we've done a lot of our work and trying to at least get one thing, right, one type. Because, working on the libraries is a lot of work, the hard work and the heavy lifting. And where we'd really like to get some help from you guys, right, from the community on as well. So, so that's some of the stuff that we're doing there. Let's kind of take a look at some other things. Let's come back here. Now, let's consider a simple case, right? Let's say you wanted to implement this thing, right? Because, after all, everybody has to implement a calculator at some point. Now, if this is the type that you wanted to build, right, there is a very, very clear mapping between this type and its corresponding C# implementation over here, right? And one of the interesting things between this and that is the fact that if you wanted a very high-performance calculator, let's say, right, it's very, very easy for you to simply write C# code and integrate that C# code without doing anything at all, right, inside of IronRuby. To answer that why question, right, like, so why is it interesting to go off and build stuff on top of .NET? And that is, you can build in a statically typed language in cases where you want performance or where you need to integrate with some statically typed library that has features for talking to the underlying platform, for example, right? And the nice thing about that is you as a Rubyist don't have to do anything, right, to do that integration. Now, it gets a little bit more interesting when your requirements are, instead of building something that looks like that, it turns into something that says, I want to build something that looks like this, right? Now, if you wanted to build something that looks like that ain't going to be all that easy to do, right, inside of C#, right, alone, unless you do some tricks. So let's go off and let's build that, right, inside of IronRuby itself, right, just to give you sort of like a bit of a taste of what it looks like to go off and build things inside of the language. So rather than spending all this time typing, since we're a little bit short on time right now, instead what I would rather do is show you a completed implementation of this thing. So if you look at that, it's essentially still the same calc type that we have here, right? Except we now have some additional annotations. Those annotations, those things inside the square brackets, are some user-defined metadata that gets injected into the generated assemblies by the C# compiler. Right? So we're essentially marking this type as being a Ruby class, and this attribute here actually picks up the name of the class here. Right? So it's now going to be a class, and this lives in our built-ins directory, so we don't have to require this thing. Right? That's just for simplicity, right, for building this demo. So there's calc. If you want to build a constructor, so you'll notice something else that's interesting here. Let's go down to some of the instance methods just so you can get a better feel for that. So that's a Ruby method. So there's calc. Question? This is Ruby specific, absolutely. So what I'm showing you here is Ruby specific. So if you look at Ruby method here, right? So because Ruby methods have different names, and we want to make sure we can pass things like fxcop as part of our build infrastructure, it's a better idea for you to use an attribute here to identify what the name is. And plus, Ruby methods can have names that are impossible, right, in C# as well. So we use the attribute to go off and define what the name is. This is a public instance method by default, right? So you don't have to add additional qualifiers, but if you wanted to create a public singleton method, for example, right, you can certainly go off and add some qualifiers, right, to that attribute to declare some of those guys. So if you look at the other interesting thing about how this is implemented is you'll notice that these things are all implemented as static methods, right? And this is done so intentionally. They're implemented as static methods because we wanted to be somewhat closer to a feature inside of C-Sharp 3.0. So C-Sharp 3.0 has an interesting feature called extension methods. And what extension methods are is the ability to walk up to an existing type and add additional methods to that existing type, right? All of that work was done to facilitate this other piece of technology called LINQ, right, which is language integrated query, which is another feature of C-Sharp VB and as well as the CLR itself. And so the idea is, you know, I'm going to build this static method, and based on what this type is here, this was C-Sharp 3, and we did that, right? That winds up being an extension method. Right now, this is C-Sharp 2, right? So we're not using C-Sharp 3 compiler yet for our work in DLR. This technically hasn't shipped yet, but it should any day now. So with calc self, so that's their self, and we do this thing, so you can understand what that code does there. The interesting bit of code is this thing up here, right, for doing the constructor stuff, right? So there's a create calc function. It's a Ruby constructor, right? So that effectively is our implementation of initialize here for the default case. And this is the other case where we have an overload, right, of that method. And that overload of that method now takes our code context and a block, right? We check to see if the block is null, and then we go off and call instance eval, right? It's pretty well exactly the same code that you would otherwise write inside of Ruby, except kind of C-sharpified, right? That's a word. So that gives you a feel for, you know, a little bit of what it would take to go off and build something that runs like this. Now, once you've built this, these attributes have to be, we have this kind of, you know, processor that we have as well, which will read this thing. Let's go off and run this thing. And if we just run rake gen off this thing, this runs our little initializer guy. And what our little initializer guy is he goes off and does, and generates a really scary looking file, right, like all code generators. And what this scary looking file does is it essentially registers all of the types, right, that are inside of our built-ins and inside of other libraries, right, and generates a function that is called during load time by the CLR when we load the compile assembly. So if you look at some other interesting things in here, let's find calc in here. Oops. There's load calc instance. So there's our methods being added, right, and all the generated goo that winds up showing up here, right? So if you're contributing to libraries, you'll be intimately, you know, familiar with rake gen, right? Because unfortunately, it's a multi-step build process, right? You add the attributes to your types, you run this thing, and you compile again, right? You got to compile once first, right, so that we can read the attributes, do the initializer gen, and then compile again, right? So there's all sorts of places where this thing breaks, but, you know, we'll fix that sometime. So that gives you a feel for what it looks like to go off and build this kind of stuff inside the language. So let's come back here. And this is just some other stuff I'm just kind of burying into the slide so that you can look at it later on. But this kind of gives you the whole big picture of that. So all that stuff in yellow is the new stuff that we added, right, to make this a C-sharp implementation of a Ruby type, right, instead of just a C-sharp type that can be consumed by Ruby. Right, so it's not all that scary, right? And it's about, we can make it a bit cleaner still, right? We're not out of tricks yet, right? But this gives you a feel for where we're at in that. Now, there's this thing, right? You know, the crazy-looking, cloudy blue thing. And that thing is Silverlight, and that's our Microsoft-created cross-platform being Mac and Windows, client-side technology. Right, for building web applications. Right, so Silverlight, you know, runs in all of the major browsers today, both on Mac and Windows. It's all confusing, right? There's a V1 thing which only uses browser JavaScript, right, to script all this stuff. V11, right, is a version that includes the CLR, right? So what's interesting about Silverlight is that the version of the CLR that we're putting in there, right, for the V11 version is 4 meg in size. It's a 4 meg download. It is the real CLR. It's not some fake CLR. It's a real CLR that's being put on a massive diet, right? Because anyone that's tried to download .NET 3.0 or 3.5 or any of those other things recently, like, knows exactly how big the CLR is today, right? So 4 meg is rather shocking. But it is a real CLR. It's a real JIT. It's a real GC. Obviously, some features had to be cut, right, in order to get it down to 4 meg. So certain things like, COM interop and remoting and stuff like that, right, don't live inside of a browser-hosted environment, right? So we don't have those things inside of that version of the CLR. But outside of that, it can run IronRuby and IronPython just fine. So let's take a look at this thing here running IronRuby and IronPython. Or IronRuby. Forget about that. IronRuby. We're at a Ruby conference. So if you look at this app here, as it thinks and shows the lovely splash screen. This is just a little app that I've been building, for a while. It shows a bunch of pictures I took at the zoo in Seattle. And so you saw the little poppy effect and all that kind of stuff, right? But what's cool about this is this entire thing was implemented inside of Ruby. And what's even cooler about this thing is that it uses a scenario that somewhat difficult to do, but once you have the sample, you know exactly how to do it. I bled some serious blood actually getting this thing to work. So let me show you a little bit more about what this implementation looks like. Let's look at scene first. So this scary-looking stuff is XAML, right? And XAML's got somewhat of a bad rap, I think, in some ways, right? Because if you think about what XAML's trying to do, what XAML is really is a way of expressing a serialized object graph as XML, right? That's all it is. XML was chosen largely because of a tooling thing, right? So generally people, humans, you guys, right, aren't going to be writing this stuff, right? It's going to be some kind of tool that's going to be generating this thing, right? So we've got a couple of tools. We've got this expression blend thing. We've got this plugin for Visual Studio. Actually, it's integrated in Visual Studio in 2008. That will go off and do this with designers and all that stuff. Because the reality is that only crazy people would go off and try and do 3D textured things, right, by typing in all the XML or whatever markup languages that they have, right, by hand. Right? You really need to use a designer tool for generating those kinds of things. But what I wanted to do was I wanted to show you this thing because this kind of gives you a little bit of a frame of reference, right, for what I'm going to show you next, right? So inside of this thing, there's essentially this stage thing that sits here, right? So this thing is the picture of the jaguar, which is an image element, right? So there's a bunch of attributes inside of there. Now, there's a couple of things I want to point out there, right? You'll see things like, this width and height, scary-looking things like, well, actually, forget about that. Let's look at width and height. Width and height, they're numbers, they're doubles, as you might expect. Source is a string, right? But it's not really a string. Right? It's going to be a URI, right? Because this thing runs in a browser, it's got to go fetch it from the server and all that kind of stuff, right? So it's really a URI. So one way of thinking about XAML is the fact that XAML really is kind of like a dynamically typed way of looking at a statically typed object graph, right? There's not any type declarations there. I don't say, well, this is a URI colon some other thing, right? So what's interesting is you can also specify other things like colors, for example, inside of XAML, right? So let's look at, I don't know, I got white here somewhere. Yeah, there it is, right? So foreground is equal to white here is another example, right? Well, what is that really, right? That turns into a solid color brush, right, inside of XAML. Or it's not inside of XAML, but inside of the object graph itself, right? So there's some interesting things here, right? There's these kind of type conversion things. It's kind of dynamically typed in the sense that there's no explicit typing inside of the XAML itself, right? And some of those properties, you can assign different things to them, right? So it's going to parse them intelligently and do different things. So I want you to kind of keep that thought in your mind when we go off and we look at this other file. So if you look at this thing here, this is essentially the same photo viewer application, but implemented entirely inside of Ruby, right? So we can look at this first thing, right? This bounce animation piece, right? So inside of the bounce animation piece, we're going off and building this thing. Right? But if you look at it, right, we've got things like, begin time is a string, right? But that begin time thing isn't a string. It has to be converted into a key time object, as it turns out, or a time span object in that case. So there's a bunch of other little bits of meta programming that have to happen behind the scenes in order to make that happen, right? Lots of standard Ruby tricks, right, for doing this stuff are being used. So let's kind of look at some of the standard Ruby tricks that you'll see. So let's go back here and let's grab the storyboard. Let's look at double animation. Ugh. So all of your friendly neighborhood Ruby methods are being used. This is IronRuby running all this code today, right? So we're going to alias off the method, right? So in this case, this is just key time. We're going to look at one of the other ones a little bit further down, right? But you can see we're going to generate a key time from a time span, right? There's a time span .parse and blah, 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 all that kind of stuff. So what's interesting is, this is still a bit of a prototype, right? To try and run this application, right? But over time, you can imagine using a bunch of Ruby metaprogramming tricks to run Ruby code inside of a browser, right? To do all these kinds of things, right? So all the standard things that you know already, right, inside of Ruby, and the metaprogramming things you can do, you can metaprogram against .NET types as well, right? Right? Because that's what we do, is we're trying to bring and bridge these two worlds together, right? So that it makes your life easier as a Rubyist, right? So it's kind of cool, right? Being able to go off and run Ruby code inside of your browser that talks to a rich rendering engine like this, without you having to context switch into some other language, right? So that's a lot of the interesting and fun things that we've been able to do inside of here. So what I'm going to do is after this, there's way too much code in here to really kind of walk through, right? But this gives you a little bit of a taste, at least, right, for how this thing works. And all of this code was the code that was just running just now inside of the browser. So I'll stick this stuff up on my blog after I'm done this thing, right? So you can go download this code and take a closer look at, how it works. And probably by the time we get back to the office, we will check in the bizarre Frankenstein bits build that we have here running on my machine that we got working at 3:30 in the morning last night that actually ran that thing that you just saw there a few minutes ago. So with that being said, let's kind of move along a little bit further, right? So that was our Silverlight stuff. And whoa, how did I get all the way down there? Okay. So that just kind of shows some of the things, right? The straight line transform of this thing. But that's what ultimately this code now looks like, right? So the types that were here, right, the yellow stuff that you see there, right, get transformed into the yellow stuff that you see here, right? So it's a reasonably Ruby-esque thing. Anything that doesn't really look Ruby-esque in here is for workarounds around some missing features that we have inside of IronRuby today, right? We're not done yet, right? So you can imagine this thing looking a little bit prettier, right, using some more Ruby Kung Fu on this stuff, right? But this actually all runs today, right, inside of IronRuby. So this is pretty good progress. So this is our storyboard, so that's the other thing, right? So, all right. So we're running low on time now, right? So what I thought I would do is we have this little event, right, that we run, that we're going to be running in January this year, right, which is the lang.net symposium. Right, so certainly I want to extend an invitation out to anyone that is interested in implementing languages on top of DLR or CLR itself, right, to join us out in Redmond to kind of, discuss a lot of these things so we can show you some of the additional work that we've been doing. And more importantly, right, we can just have more of a dialogue with you about what it takes to build interesting languages and implementations on top of our platform, right? Because we're really serious about this stuff. It's a lot about giving folks choice. We are a developer company, right? We are a platform company, and this is how, ultimately, my mortgage gets paid. Right? So, so at the end of the day, thank you very much for being here so early in the morning, right? Listening to me ramble on about this stuff. But I want to open it up to some questions. How much time do I have for questions? Yeah. So start asking questions while they figure out how many questions I can answer. Okay. No questions at all. Yes.
Do you have a time frame for release schedule yet?
So we are. So the nice thing about not being a quote unquote real product group at Microsoft, right? Which where we get tied to schedules and all this other crazy stuff that marketing guys dream up. We are a conference-driven, schedule, right? So we've got this roadmap of conferences, right, where we have different milestones that we wanted to get working, right? So obviously here we have to do a lot of work to get our .NET Interop and our Silverlight stuff back in sync with the bits that we haven't looked at in a long time. So our next conference, that we're looking at is going to be the Microsoft's little conference in Vegas called Mix, and so there, in terms of milestones, we're planning on showing some of our work for integrating in with the server-side stuff, right? ASP.NET and a bunch of other things, right? So running IronRuby on the server. That happens at the end of March, I think it is. Yeah, I think it's at the end of March. And then after that, there's RailsConf. So we want to try and do this kind of steady march towards RailsConf next year. And the goal certainly by RailsConf next year is see if we can actually get Rails running in some way, shape, or form. Right? So those are my weasel words, right? On top of IronRuby by then. There's going to be a lot of work to happen in the libraries, right? So that's essentially our roadmap, right? We post that, we'll see, right? It all depends on how we get from here to there, right? So the great thing is that those are essentially our major conferences we got on the roadmap. One more? Okay. Sure. So the question was, there have been concerns from pundits, right? And myself, right? So about our inability to go off and look at the source code for certain things, right? Other implementations and other things. So to be clear about what that really represents is, if you look at what happened in IronPython, right? So IronPython was our first foray into this stuff. But the genesis of the DLR was IronPython itself. So traces of direct lineage back to that. And the DLR is a piece of software that's going to ship inside the operating system. It's going to be part of the CLR, and CLR is part of the operating system. So that lineage is very important, right? So we got to make sure that we're very clean on the intellectual property, right? Because not a lot of people like us, right? So the thing about that is making sure we have that clean heritage there is very important for certain pieces, right? Which is things like DLR. Now, IronRuby, on the other hand, doesn't really have the same restrictions, right? We are probably not going to ship inside of any operating system or any real product, right? You can download it and run it, right? So that's up to the user to make that choice, right? So because of that, we are under much less restrictions in that than certainly folks that were working on DLR, right? So it's kind of boring legal mumbo-jumbo stuff, right? But we certainly can look at tests and test frameworks and other things, right, to make sure that our things work. Right, so it's the same thing, right? So because we are not shipping inside of some other Microsoft product, right? It's fine, right? It's just this piece of code, right? You can download it like any other kind of extension or add-on, right, that the company creates. Okay, so I think I'm out of time now, but thank you guys very much, and I'll be happy to answer questions and stuff afterwards.